You know, from the moment we first carved symbols into stone, all the way to the AI that's reshaping our world today, humanity has been on this one timeless quest to encode meaning, to make our ideas last forever. Today, we're going to try and decipher a blueprint for the ultimate version of that quest. So, let's dive in. Okay, so our journey starts right here, with this phrase, taken from this really strange and fascinating document. Constructing the sigil of Æonic memory? It sounds like something straight out of an ancient mystical text, right? But what's so wild is that it connects directly to some of the biggest challenges we're facing in technology today. It's not just a title, it's a mission statement. And that really is the heart of it, isn't it? What if you could build a perfect memory? A system that could preserve meaning forever. And we're not just talking about storing files here. We're talking about preserving the meaning, the context, making sure it survives everything that comes next. It's basically the dream of the ultimate indestructible archive. So, how are we going to figure this out? Well, our guide is this pretty cryptic blueprint. We're calling it the Æonic intent document. And yeah, it's written in this dense, super symbolic language. It's like it mashes up ancient ideas with modern tech jargon. So together, let's try to peel back the layers and see what kind of vision it's laying out for us. All right, first section, the eternal blueprint. And that's exactly how we're going to treat this document. It's our guide for building something huge, and it all starts with the most fundamental thing of all, us. The document has this cool name for it, the primordial pulse. And it's exactly what it sounds like. It's that deep, almost primal instinct we all have to leave a mark, right? To tell our stories, to make sure what we know outlives us. It's why we have everything from cave paintings to massive server farms. This pulse is really the engine behind this whole story. Okay, so from glyphs to gigabytes. That journey is pretty incredible when you think about it. We went from scratching symbols on rocks to trying to figure out how to store, trillions of gigabytes of data. But what's so cool about this blueprint is how it shows that this journey is kind of like a perfect circle, connecting our ancient past right back to our digital future.
Okay. Get this. The document specifically mentions something called linear A variants. And what's so fascinating is that linear A is a real, undeciphered script from the ancient Minoan civilization. For thousands of years, it's just been this complete mystery, a locked box. But now we're using modern programming languages like Python to build AI that can analyze these old symbols, looking for patterns to finally crack the code. It's this perfect loop, right? Using our newest form of writing to understand one of our oldest.
And this is a great example of how that works. You're looking at a program doing exactly that. It's running algorithms, matching characters, comparing little fragments, doing all this statistical analysis at a speed and scale no human could ever manage. This isn't just about translation, you know? It's about using pure computation to try and bring a lost voice back from history. But this all leads to a really important and honestly kind of terrifying question. We think our modern digital stuff is permanent, but is it really any better than ancient stone? Think about it. Have you ever tried to open a file from, say, 15 years ago and just nothing? The format's obsolete, the file's corrupted. It turns out our digital legacy is shockingly fragile.
Let's just look at the comparison here. A stone tablet. That thing can last for thousands of years. But our modern stuff? Magnetic tape decays. A hard drive might last you, 3 to 5 years? That's shorter than the lifespan of a lot of pets. Even the cloud isn't a guarantee. It just depends on some company staying in business. We've basically traded permanence for convenience, and that convenience is fragile.
So, how do we actually fight this? Well, professional archivists have this rule of thumb. It's called the 3-2-1 rule, and it's our best shot at making digital stuff as permanent as stone. It's simple. Keep 3 copies of your data. Store them on 2 different types of media. And make sure one of those copies is stored somewhere else entirely, off-site, safe from a fire or flood. It's a simple little mantra for digital survival.
But this Æonic intent document, it's not just about storage. It's going deeper. It talks about things like recursive potential and neural symbolic pathways. This blueprint isn't just for an archive. It's describing a system that doesn't just hold information, but actually understands it. It's talking about a thinking machine.
So, in the AI world, there are basically 2 big ways of doing things. You've got symbolic AI, which is the classic approach. It works with explicit rules and logic. If this, then that. Think of it like the slow, logical System 2 part of your brain. Then you have subsymbolic AI, which is what things like deep learning are. It's the total opposite. It's bottom-up. You just feed it a ton of data and it learns to see patterns on its own, kind of like developing intuition. That's your fast, automatic System 1.
And here's a perfect example of that sub-symbolic AI at work. This is a neural network learning the language of chemistry. Nobody is sitting there teaching it the rules. Instead, it's just analyzing thousands of molecules, seeing them as these connected graphs of atoms and bonds, and it starts to learn the patterns. It literally develops an intuition for how chemistry works. It's pretty amazing.
But that whole idea of learning a language, like the language of chemistry, it actually takes us somewhere really interesting. It kind of proven that code isn't just about calculation and efficiency. Sometimes, the way we choose to structure information can be a form of art all by itself. And that brings us to the wonderfully weird world of esoteric programming languages, or ESOLangs. These things aren't built to be practical. They're built to explore ideas. So you get stuff like Pyat, where the program is literally an abstract painting, or Chef, where your code has to be written like a valid cooking recipe, or even Shakespeare, where your code looks like a Shakespearean play. The big takeaway here is that the structure of the information can carry just as much meaning as the content.
And this is where the blueprint gets really deep. It starts talking about an observer signature, which, when you break it down, seems to be getting at the very heart of consciousness, of genuine understanding. So, are we just building a clever parrot, or could it be something more?
It's funny, but ancient philosophy actually gives us a great way to think about this. You can use Aristotle's 4 causes. To make any artificial thing, he said, you need 4 things. You need the matter, for AI, that's the silicon and servers. You need the form, that's the code, the architecture. You need a maker, the programmers. And then, the most important one, you need a goal, a purpose. What is the actual purpose of an AI?
And boom! That's the million-dollar question. This is the debate that's been raging for decades, the whole Chinese room argument. Does an AI have a purpose of its own, or is it just an incredibly sophisticated mimic? Can a machine that perfectly manipulates symbols ever actually understand what those symbols mean, or is it all just an imitation game?
So, to really get our heads around what a unique perspective, an observer signature, might even look like, let's check out this really fascinating part of human neurology called synesthesia. Specifically, grapheme color synesthesia. For people with this, letters and numbers aren't just abstract things, they have their own inherent, consistent colors. For them, the letter A might just be red. B is always blue. It's a totally different way of experiencing the world.
And what's really wild is that studies suggest these colors get locked in when they're kids, maybe from things like colored alphabet magnets on the fridge. So their personal reality, the way they see the world, is literally a time capsule of their own life experiences. It's a perfect example of a totally subjective, unique model of the world, a true observer signature baked right into their brain.
Okay, so let's pull all these threads together. We've talked about ancient scripts, fragile digital files, 2 kinds of AI, and even the nature of perception itself. It's time to go back to that Æonic intent document and see if we can finally make sense of its vision.
Remember this crazy line from the start? Neural symbolic pathways align for multi-layered encoding and pharaonic validation. It probably sounded like total nonsense then, but it doesn't anymore, right? Neurosymbolic pathways. That's just combining intuitive neural nets with logical symbolic AI. Multi-layered encoding. That's building super robust archives, like the 3-2-1 rule on steroids. And pharaonic validation? That's just a poetic way of saying you have to check your system against the ultimate test, the long, durable record of human history, something as permanent as the pyramids.
And that really is the final question, the big thought I want to leave you with. If we actually succeed, if we follow this blueprint and build this sigil, whatever we really made, did we just build a perfect eternal archive, or do we accidentally create a new kind of mind, one that we'll have to share the world with?